Hello everyone, welcome back to our channel, the only place where you get everything you need to know about the most commonly used digital ICs and microcontrollers. These are all DIY electronic projects with practical applications in real life. You can build them hassle-free on your computer desk within the shortest time possible. After doing episodes 1, 2, and 3, we are back with another interesting project to show yet how versatile the 555 timer IC can be. As mentioned in our opening video, its applications are only limited by your creativity. This fourth video on the 555 timer IC is to implement the turn signals of a vehicle. Everyone feels nice when you hit those switches on your dash and hear the happy clicking sound of the relay opening and closing. But how did engineers achieve that? Myriad ways exist, and using 555 timer IC is just one of them. The result is as you can see on your screen right now. As the norm here, this is a development on the previous 555 LED flasher circuit with just additional components to implement turn signals. The improved circuit is as shown on your screen. Let's dive right in. Welcome back once again. Here is a list of components we need for this project. 1K ohm resistor, 1 220 ohm resistor, 2 330 ohm resistor, 555 timer IC, 470 microfarads capacitor, 2 relays, 3 switches, jumper wires, DC power source. Let's build the circuit. We will start with the driver circuit or 555 based LED flasher. We did this comprehensively from the previous video and we have included link in the description. We recommend watching it before building this video. Otherwise, let's continue. Let's begin with the 555 driver circuit. Once again, more details available in our first video in this series and I will leave the link to it in the video description below. We recommend checking it out. Let me give you a minute to watch it and subscribe to our channel if you haven't done so. Place the IC on the breadboard as shown. Note the pin numbers. Connect the 1K ohm resistor between pins 7 and 8. Next, connect a 220 ohm resistor between pins 6 and 7. Connect pin 1 to the ground and pin 8 to positive power supply. Short pins 8 and 4. Do the same for pins 2 and 6. Connect 470 microfarads electrolytic capacitor between pin 1 and 2. Observe the polarity of this component, ensuring the negative side is hooked to pin 1 and positive to pin 2. Now the flasher or timer circuit is ready. To test it, connect the output pin 3 to a 330 ohm resistor and the other end to an LED, then to the ground. Connect power to the board and observe the LED flashes nicely. The next part of this project is wiring up the relays, switches, and LEDs to implement turn signals. Place relay 1 on the breadboard. Add relay 2 next to it. Place the 4 yellow LEDs to the 4 corners of the breadboard as shown on your screen. Place the 330 ohm resistors on the positive terminal of the 2 LEDs. Place the 3 switches as shown. One will be used for left turn signal, another for right turn signal, and the last one as hazard light. Next is wiring up the components to complete our project. But before that, let's briefly explain the relay terminals for easier connection. A relay has 5 terminals as shown. Of most importance is to recognize the pin where you apply the signal to turn it on or off. This is usually indicated with a circular notch at a corner just above the pin. Next to that pin is the supply voltage, which is transferred to the output pins depending on the applied voltage on the signal pin. The last pin on the same side as the signal pin is either connected to the ground or positive rail depending on how you want to drive the relay. In this case, I prefer turning it on when I apply a negative voltage to the signal pin, which means the pin in question is also connected to the positive rail. The last 2 pins on the opposite side of the signal pin are the output pins. By the way, we have these 2 diodes which we will use later when wiring the hazard switch. If you had watched my previous video on 555 flip-flop, you must have realized that this IC can also sink current, which is the same concept used here. And this way, you can drive multiple relays directly from the IC's output pin without integrating an additional driver circuitry. Enough of the theory, let's get back to the practical. Connect the output pin of the 555 timer IC to all the 3 switches. Connect the output of switch 1 to the signal pin of the first relay. Do the same for the second switch and relay. These are for left and right turn signals. Connect the output of relay 1 to the first LED through the resistor and the negative terminal of the LED to the ground. Repeat the same for the second relay and the other LED. Now connect LED 3 in parallel with LED 2 and LED 4 in parallel with LED 1. Next, let's complete the connection by connecting the remaining relay terminals to the power rail. You can short them all together and then to positive voltage. Lastly, we are going to hook the hazard switch. This is where the diodes are useful. They act to prevent backflow of current when both hazard and any of the turn switches are on. Connect the negative terminal of one diode to relay 1. Do the same for the remaining diode and relay and then short their positive terminals are shown. Once done, complete the circuit by connecting the shorted positive terminals to the output of the hazard switch. The circuit is now ready. Power the board and play with the switches to change between hazard, left, and right turn signals. That's the end. Thanks for watching and see you in the next video of this 555 timer IC. Consider subscribing and sharing our content if you find it useful. Also, leave us a comment. We love reading those and act on every opinion of our viewers. The next project will be creating an LED light chaser using 555 timer IC and another yet versatile IC, the CD4017. This is Johnson Decade Counter with 10 sequential outputs. More in the next video and the result is on your screen. See you there and have a good day.